For our first investigation, our research question is, how does a change in temperature affect the surface tension of water?
For the second investigation, our research question is, how does the change of salt concentration affect the surface tension of water?
Our independent variable for first investigation is temperature. For the second investigation is the concentration of dissolved sodium chloride. Our dependent variable is the number of staples staying afloat. Our controlled variable for both investigations is the type of staples, the area and the material of the paper. For the first investigation, we keep the purity of water the same. For the second one, we keep the same temperature of water.
We hypothesize that there will be a negative correlation between temperature and the maximum pressure that 2 cm square paper can withstand. We hypothesize that the higher the concentration of salt, the weaker of the surface tension.
First, the average mass of one staple is measured from a sample of 50.
A piece of paper with an area of 2 cm square is placed on the water.
Staples are added one by one until the paper can no longer float.
The maximum number of staples that the paper can withstand before sinking is then recorded.
Each trial is repeated 3 times and an average is obtained. The experiment is repeated with a range of temperatures from 0 to 60 with intervals of 10 in between.
For the second investigation, prepare 250 ml of tap water using a volumetric flask. A 10 gram of salt is measured using a balance and then dissolved into the water. The solution is stirred.
The total weight of the staples is divided by the surface area of the paper to find the pressure acting on the surface of the water.
Supports our hypothesis, as an increase in temperature results in a decrease in the strength of the surface tension, exhibiting a negative correlation. There is an anomalous data point at 12 degrees. This may be due to the reasons suggested in the evaluation section.
In the second investigation, a similar negative correlation is observed between the molarity of the NaCl and the pressure that was withstood on the surface of the water.
Surface tension is due to the cohesive properties of water, which is caused by the intermolecular forces. In water, the strongest intermolecular force is hydrogen bonds, which is the electrostatic attraction between the positive dipole hydrogen and the negative dipole oxygen. At higher temperatures, molecular motions and vibrations increase. The bond strength diminishes as the distance between water molecules get larger, and so the cohesion of water decreases, leading to a weaker surface tension.
In the second investigation, when salt is introduced to the water, it dissociates into Na+ and Cl- ions. These ions are surrounded by water and thus forming onion-like structures. These essentially disturb the hydrogen bonding of the water, reducing cohesion and thus weakening the surface tension of water.
Sometimes the paper sunk not because of the weight of staples, but because it was dampened by the water. Use a stiffer and less absorbent paper material, for example, cardboard or aluminum foil, that can withstand more moisture and for a longer period of time.
The temperature of the water bath do not necessarily remain constant throughout the experiment and between different repeats. Heat can escape via conduction or radiation. The improvement would be to insulate the water bath with cotton or foam throughout the trial and to conduct the experiments quickly to minimize heat loss.
Sometimes the staples cheat by hooking to each other or to the side of the container and does not lie directly on top of the paper. To improve that, we promptly remove these cheaters with forceps.
Since staples are reused, they may accumulate moisture after each trial and increase in mass. This would affect the average mass of each staple and the number of staples staying afloat. Dry the staple by heating or with a blow dryer to get rid of moisture on the staple after each trial.